Hello, this is Ms. DB, and in this lesson we're going to review how to simplify algebraic expressions. This goes along with the Chapter 1, Section 4 assignment in your folder. Our objective is to simplify and evaluate algebraic expressions. This should be a review from Algebra 1 or Algebra 1.5 if you attended here. Here's an example problem of why we might need to do this. There are three different ways in which a basketball player can score points. There are free throws, 1 point, field goals, 2 points, and 3-point field goals. An algebraic expression can represent the total points scored during a game. So they're using F for free throw, they're using G for 2-point field goals, and they're using T for 3-point field goals. So these are the variables, the F, the G, and the T, and then the numbers in front of them represent how many points each would be. Now you could also put a 1 in front of the F because 1 point times every free throw is how you get that point part. So that's an algebraic expression. It's a useful thing to know how to do. Alright, so here are some different things that are happening and what we would do if those things were happening. So if we have to combine something, we probably mean to add. And if you're reading a problem, it probably is going to say something like how many total or how many are there. If we have to combine equal groups, that generally means to multiply. If we have to separate something, that means to subtract. And if we have to separate into equal number of groups or equal parts, then that usually means divide. So those are just some keywords to look for. So here's some examples like you'll have on your worksheet. It says to write an algebraic expression to represent each situation. The number of apples in a basket of 12 after n more are added. So we started with a basket of 12 apples and we want to add n more. Well, n is a variable, so we're just going to write 12, that's our starting number, plus n. You don't have to solve these or anything, you're just going to write an expression. How about the number of days it'll take to walk 100 miles if you walk m miles every day? Well, let's break that down. What if we walked 100 miles in 2 days? Well, that's 50 miles a day. So we could get that by taking 100 divided by 2 would equal 50. So try a simpler problem if you're not sure how to write it. So 100 over m. We do not use the division symbol like this in high school, in Algebra 2 at all. We'll use the fraction bar or this on the keyboard. You should remember this. This is order of operations. Very, very important. Now you might have learned this differently, but PEMDAS, or please excuse my dear Aunt Sally, is a very important or useful way to remember the order of operations, which are so important. So this tells us that the first thing we need to do is the P, which is parentheses, or grouping symbols. Next we do the exponents. Now here's where some people mess up. It's not multiply first and then divide. These have equal power, so we just go from left to right when we see these. If division is first from left to right, then we divide first. If multiplication is first, then we multiply first. And then addition and subtraction are also the same. Equal power, just go from left to right. This could be DM and this could be SA. So the MD are together and the AS are together. They are not separate. You don't have to do all the multiplication and then all division. You just do these together as you find them. And you do these together as you find them. Here's an example. It says to evaluate the expression for the given values of the variables. So in this one, we'll use PEMDAS, but first we have to take what x is equal to, which is 5, and every time we see an x, we have to replace it with 5. And then we also are given that y is equal to 2. So every time we see a y, we'll put a 2. And note that if there's two variables next to each other, we're multiplying. If there's a number in a variable, we're multiplying. So we're just going to go through first and replace each variable with what it's equal to. So x is equal to 5. Y is equal to 2. There's another y is equal to 2. And then our next step is to simplify using, oops, not a B, a P. So is there any parentheses? No. Is there any exponents? No. So our next step is to do any multiplication and division as it shows up. Multiplication, lots of it. There's a 10, there's a 10, there's an 8. Okay, we did that step. Now we do any addition and subtraction as it shows up. Now in this case, subtraction shows up first. So 10 minus 10 is 0, plus 8 is going to be equal to 8. I kind of covered up their little spot, but we ended up with the same exact answer, and we got 8. All right, here's another example. First thing to do is replace every R that you see with a 3 and every Q that you see with a 7. Which brings us to 7 squared plus 4 times 7 times 3, parentheses is another way of showing multiplication, minus 3 squared, because R is 3. Next step then is to use PEMDAS. Is there any parentheses? There is parentheses here and here, but they are a short, it's not like there's a parentheses with a bunch of stuff inside of it. These parentheses mean to multiply, and these mean to use an exponent. So we're really going to go to the exponent step and simplify that. So 7 squared is 49, 3 squared is 9. Then we'll do the next step, which is any multiplication or division as it shows up. So we just rewrite the 49, and then we multiply these three things together and got 84. And then finally we'll add and subtract from left to right. And when we do that, we get 124. And that's our final answer. Here's a couple more examples. Let's do these steps together. So we first are going to replace A with 5 and B with 8. Then we'll use PEMDAS. So there's no parentheses, but there are some exponents. So 5 squared is 25, 8 squared is 64. Did that step. There's no multiplication, there's no division, so we will move to the addition and subtraction row, and we'll add 25 plus 64 together and get 89. Oh, I forgot the minus 2ab. So I will go back and go minus 2 times 5 times 8. Let me erase this. And then that means that right here I would have some multiplication to do. So here's our 25 plus 64 minus 2 times 5 times 8. And then you could kind of do that in the same step. But now we'll do our multiplication row, which is 2 times 5 is 10 times 8 is 80. And then I'm moving over a little bit because I'm running out of room. Now we will do our addition and subtraction in order from left to right. So 25 plus 64 is 89, minus 80 is equal to, now we can do our subtraction and get 9. I almost forgot part of the problem there. All right, and then the last example of this type of problem is 3xy over x squared minus 9y plus 2. We'll replace all the x's with 2's and all the y's with 4. Now this is a division sign, but it's also a fraction bar, and it's also a grouping symbol. So it's grouping the numerator, the 3xy, or 3 times 2 times 4, as one grouping, and then the bottom is also a grouping. So when we do parentheses, parentheses also is grouping. You could call it a G instead of a P. So we're going to work with the top as one group and the bottom as another group. So on the top, let's simplify the top. We don't have any exponents, but we do have some multiplication. So I'll do 3 times 2, which is 6, times 4 is 24. Okay, now I'm going to move to the bottom because that's another group. And now I kind of start over with my order of operations, and I say, let's see, do I have any parentheses within that group? No, but I do have some exponents. So I'll simplify my exponents. 2 squared is 4. I'll just rewrite the rest for now. Now, as you practice these more and more, you'll start doing combining steps. So 4 minus, now I'm going to do any multiplication I see, which is 36. And then finally, I can do my addition and subtraction in order from left to right. So 4 minus 36 is a negative 32, plus 2 is 24 over negative 30. And then your very last thing you need to do is simplify this, because this is a fraction and it's not simplified. So we'll divide both of those by 6. Divide by 6 in order to simplify our fraction, and we'll get negative. The negative can be just out front, 4/5. That one was a lot of steps for that one. In simplifying expressions, a lot of times what that means is combining like terms. Like terms have same variables raised to the exact same exponents. So in this example, x squared, they're the same variable, x and x, and they have the same exponent. So if there was an x here, that wouldn't be a like term because that doesn't have the same exponent. Constant terms are when you just have a number with no variable. So in this one, the like terms would be 3x squared and 4x squared, and the sign in front of them goes with it. And then the constants also can be combined, so we'd have 2 minus 1. So when you are going to simplify an algebraic expression, all you have to do is look at their coefficients, their numbers in front, and combine those. Don't change the variable term at all. Also remember that if you have a variable term like x squared with no number in front, it implies that there's a 1 there. So you can always add a 1 to make it easier for you to remember when you're combining your like terms. Let's look at some examples. Here we have 3x squared plus 2x minus 3y plus 4x squared. The first thing to do is to find the like terms. In this case, 3x squared and 4x squared are like terms. The plus sign in front of the 4x squared goes with it. So we combine those to get 7x squared plus 2x minus 3y. Now 2x and 3y are not like terms, so we just write them, and that's our final answer, 7x squared plus 2x minus 3y. All right, this one says to simplify, but we're going to have to use the distributive property first, which you've learned about in a previous class. So let's go ahead and multiply everything in the first parentheses by j. So we'd get 6jk squared plus 7jk, and then we already had plus 9jk squared minus 7jk. And then find the like terms. In this example, they have the like terms the same color. So the red ones go together and the blue ones go together. The signs in front of the term go with them, so that minus 7jk has to be the minus sign. Now what is 7jk minus 7jk is 0. So these actually are going to cancel each other out, and we're just going to be left with 6jk squared plus 9jk squared is 15jk squared. So we don't change the j or the k squared, we just add the numbers in front of it. Here's a couple more examples. We have 4a squared plus 5ab minus 4a squared minus 2ab minus 7. Let's find the like terms. This has an a squared, this has an a squared. Let's find, here's a 5ab, here's a minus 2ab, and then the minus 7 at the end is just a constant. That's the only one. So now we combine, and what happens when you take 4a squared minus 4a squared? Remember, the sign in front has to go with it, so those are going to be 0. So then all we really have to combine is the 5ab minus 2ab, because there's a minus in front, and then don't forget about the minus 7. So 5 minus 2 is 3, and then rewrite the ab, minus 7 would be the answer. Okay, this one is an example where you have to use the distributive property first. So we'll take 3 times s and then 3 times minus 4t. So we get 3s minus 12t, and then plus 3s minus 1t. I'm going to put a 1 in front of that t so I don't forget about it. And then we combine our like terms. This time we have 3s plus 3s, and then we have negative 12t minus 1t. Okay, so we have 3s plus 3s. You can do this off to the side if you want. That's 6s. So I'm going to have a 6s, and then I have a negative 12t minus a 1t. They're both negative, so I'll get negative 13t. And there's my final answer. Okay, there are some good application problems that you can do with expressions and simplifying. In this example, apples cost $2 a pound and grapes cost $3 a pound. And all they are asking you to do is write and simplify an expression for the total cost if you buy 10 pounds of apples and grapes combined. So we're going to let A be the number of pounds of apples. You could have picked another letter, but A makes sense since it's apples. And instead of saying G is equal to grapes, which you could do, the number of pounds of grapes, instead let's write it in terms of. So if A plus apples plus grapes equals 10, then we could solve this for G and say, okay, if I want to know what G is equal to in terms of A, I would get G equals 10 minus A. That's what they're using. So really, 2 times the number of apples plus 3 times the number of grapes, or number of pounds of grapes, but grapes is 10 minus A, is going to be equal to how much we are going to buy. So we're going to simplify this. So we use the distributive property here. 3 times 10 is 30, 3 times A is 3A. And then we combine our like terms, and 2A minus 3A is negative 1A. So our expression simplifies to 30 minus A, or 30 minus 1A. Here's an application in geometry. Let's say we have this shape, and we are asked to find the perimeter. So we find perimeter by adding up each side. And each side is labeled 2A, A, 2B, A plus B, A, and 2A plus B. They're all labeled for us. Sometimes we might have to find a side that's missing, but in this one, everything's there. So we would just go ahead and write that. I'm going to start at the 2A. 2A plus 2B plus A plus B plus A plus the last one, 2A plus B. Now remember that each of these A's is really a 1A, or if there's a B by itself, that's a 1B. And then we will just add up how many A's we have plus how many B's we have. And I'll let you finish that one up. So thanks a lot. Have a great day. Please email me or call me if you have any questions as you're working on your assignment for this lesson. Thank you very much and have a great day.